All right, this is AP, AB, and BC Calculus. We're doing Unit 7, Section 2, which is verifying solutions for differential equations. All right, so let's go ahead and get started. So if a function f of x is a solution to a differential equation, it means that the function makes the differential equation true for all x, or t, or whatever the independent variable is that's involved. While we have not yet learned how to solve differential equations, we'll do that for some types of diffie-qs soon. You can check if a given solution satisfies a differential equation. When we say verify the solution to a differential equation, we're totally saying that the function works, but you have to show that it does by plugging in and verifying that you get a true statement for all x. There are infinitely many general solutions to many differential equations, like not everyone, but many. Once we learn how to solve them, then we'll discuss how we can find these infinitely many general solutions and then also use specific values provided to find particular solutions given a set of data. So, which of the following functions, we're going to choose any that work, this is not multiple choice, multiple could be correct, is a solution to the given differential equation. So our diffie-q is y double prime minus y equals 0. So to see which one's true, I need to essentially find y double prime for each one of these and then see if when I do y double prime minus y, I get 0 for all x. So y prime for this 2e to the 2x is going to be 2e to the x rather, is going to be 2e to the x. And y double prime is yet again going to be 2e to the x. So if I do y double prime minus y, right, and I'm trying to see if it equals 0, this would be a 2e to the x minus 2e to the x, and that does equal 0 for all x, so that's true, right? It doesn't matter what x is, 2e to the x minus 2e to the x is 0. Let's try it for the next one. Y prime for 3e to the negative x is a negative 3e to the negative x, right? Y double prime is going to be, drop the negative down in front again when I differentiate again because of that chain rule, right? I'm going to have to multiply by a negative 1 because of the chain, right? And I'm going to get another 3e to the negative x. So I get 3e to the negative x minus 3e to the negative x. And sure enough, that's also a 0 all the time. So that one's a yes. So A works and B works. When I try for x squared, my y prime is going to be an 8x, right? And my y double prime is going to be an 8. Well, that would mean that we're looking for 4x squared minus 8 to equal 0. And that's not true for all x, right? I could solve this, right? But it has to be true for all x's. See how here I got something minus itself gives me 0 no matter what x is? So C is not a solution. And then c e to the x, well, y prime would still be c e to the x, and y double prime would still be a constant times that e to the x. So I get c e to the x minus c e to the x equals 0. Sure enough, that's 0 equals 0 all the time. So A, B, and D all work in this instance. All right, let's go ahead and try another one. Which of the following functions, and again, we're going to choose any that work, is a solution to the given differential equation. Now notice here I need y double prime, y prime, and also y. So I'm just going to go ahead and bust out all two of these values for each one of these, and then I can go ahead and check them. So my y prime here is going to be a 10e to the x, and my y double prime is also going to be a 10e to the x, right? My y prime here is going to be an e to the negative x times that negative 1, so negative e to the negative x, and my y double prime will be that whole thing times a negative 1 again, so I'll get back to e to the negative x. For this one, my y prime is going to be a 3x squared, and my y double prime is going to be a 6x. And then for the last one, my y prime is going to be a negative c e to the negative x, and my y double prime, I'd multiply by the negative again, and I'll just get a c e to the negative x. All right, so now let's check and see which ones of these work with this statement, right? So y double prime plus 2 of y prime, so that would be a 20e to the x, plus this will be a 10e to the x, is supposed to be 0. Well, this stuff is a 40e to the x, this is not a 0, right? I need it to literally be 0 equals 0, not something that I'd solve for x, so A is a no. For the second one, y double prime is an e to the negative x. Y prime is a negative e to the negative x, so this will be a negative 2 of those, right? So negative 2e to the negative x, right? Plus this is an e to the negative x, equals 0. Well, I'm pretty sure that there's a positive 1, another positive 1, and a negative 2. That's 0 of these. 0 equals 0. That one's true. For the next one, I get an x cubed plus a 6x squared plus a 6x equals 0. That's not 0 for all x, right? So that's not 0 for any x, right? The goal is it has to be true for any x value ever, and while it is 0 for certain x values, like x is 0, it's not 0 for every x value, so that's not a solution to the Diffie-Q. And then for this last one, my y double prime is a c e to the negative x, plus 2 of this y prime, well, that's going to be a negative 2c e to the negative x, plus the other c e to the negative x, that's my y, equals 0. Well, sure enough, if I add, this is one c and another c, that's 2c and a negative 2c, I get 0 equals 0 all the time, which is true. So B and D are solutions to this particular differential equation. All right, so we're going to determine if this given f of x is a solution to this differential equation. So I need a y double prime and I need a y prime, or an f double prime and an f prime in this case. So let's go ahead and differentiate, right? So f prime should be 2e to the 2x, right, because of the chain rule, right? Derivative of e to the 2x is e to the 2x times the 2, plus a 3, right? And my f double prime should be a 4e to the 2x, and that's it, right, because the 3 disappears. So when I test this, the question is 4e to the 2x minus 2 times this whole ugly monstrosity plus a 7, is that equal to 1? If I get a 1 on this side when I simplify, so 1 equals 1, then the answer is yes, this is a solution. So this is a 4e to the 2x minus a 4e to the 2x minus a 6 plus a 7 equals a 1. These two sum to 0. These two sum to a 1, so I get 1 equals 1, and the answer is yes, it's a solution. Because again, true for all x. 1 equals 1 is always true. Let's try a P2. Same concept. Again, I need an f double prime here. I don't actually need f prime, but you can't get to f double prime without finding f prime first. So f prime is going to be, when I differentiate the e to the negative 3x, it's going to be a negative 3 e to the negative 3x because of the chain rule. When I differentiate sine, I get cosine, but I need to multiply by 3 because of the chain. So I'm going to get 3 cosine of 3x. So when I find my f double prime, right, this is going to end up getting multiplied by negative 3 again because of the chain rule. So I'm going to end up with a 9e to the negative 3x, right? Because the derivative of negative 3e to the negative 3x is a negative 3e to the negative 3x times a negative 3. When I differentiate cosine, I get negative sign, and then I'm going to have to multiply by the 3 again because of the chain rule, right? So I get this as my f double prime. So now I'm checking that this and this plug in correctly to give me a 0. So let's see what happens. F double prime is a 9e to the negative 3x minus 9 sine of 3x minus a 9, and then in parentheses, I'm going to go ahead and write what this original function is. Right, so now we're going to clean up, and the question is, does this equal 0? So I have a 9e to the negative 3x minus a 9 sine of 3x minus a 9e to the negative 3x minus a 9 sine of 3x equals 0. Well, these two sum to 0, which is great, but these two don't because they're both negative 9s. Now, it's not a bad idea to go back and double check your sign and make sure you didn't do anything silly, but I know the derivative of sine is positive cosine, and I know the derivative of cosine is negative sine. So my signs are right. So I get a negative 18 sine of 3x equals 0. And so my answer is no, it's not a solution. Right? Because again, to be a solution to the Diffie-Q, I need to get 0 equals 0, and this is not always 0. Right? It could be 0 for a second, but it's not always 0. So I need literally 0 equals 0, or 1 equals 1 like we saw in the last example, right? All right, so in example 2, things are a little bit trickier. So this is a little bit more akin to something that you might see on an AP, maybe as multiple choice, maybe as free response. So we're going to find the values of a and b such that y equals ax plus b is a solution to this differential equation, right? Okay, so let's start by taking this solution. So we know that this is a solution, we just have to find the correct values of a and b, right? So we know that y equals ax plus b, and if I differentiate, right, dy dx, the first derivative, should just be a, right, because b is a constant, so it's just going to be a. So what we're going to do, right, is we're going to go ahead and plug in, right, and we're going to get that dy dx can be replaced with a, right, and y can be replaced with ax plus b. So we're going to get a equals x minus 4, and then in place of y, I know that y is supposed to be ax plus b, plus a 17 over 4, right? So let's clean this up a little bit. I have a equals x minus 4ax minus 4 plus 17 over 4. Okay, so remember that this has to be true for all x's in the whole world, right? You're not solving specifically for any x, right? So because this has to be true, right? This has to be true for all x's, right? There are a couple ways to deal with this, right? One way to deal with this is to say that that means that for all x, so the left-hand side has to equal the right-hand side regardless of what x is. If that's true, then what it means is that on the left-hand side, the x's have to equal whatever the x's are on the right-hand side, right? Well, there's no x's on the left-hand side. There's only this a. And on the right-hand side, the x's are 1x minus 4a, or if you want to just note what the coefficients are, right? That's a 1 minus 4a, right? Because we can say that this is a 1 minus 4a, whatever number that is, in front of the x, right? That's what this is. So the a's, right, the x stuff on this side, which is none, have to equal the x's on this side. Well, that alone lets me find a. If 0 equals 1 minus 4a, then 4a is 1, and I now know a is 1/4. Similarly, the numbers on the left-hand side, which are in this case just a, right, have to equal the numbers, which are the negative 4b plus 17/4 on the other side, right? So negative 4b plus 17/4. But since we already know what a is, right, we can say, oh, I know that a is 1/4, and that's a negative 4b plus 17/4. But when we solve, we'd subtract the 17/4 over, right? And I'm going to get that this is a negative 16/4 equals negative 4b. Well, that's negative 4 equals negative 4b. B is 1. So the a and b that make this expression true, so a is 1/4, b is 1, right? So essentially, the solution to this differential equation is y equals 1/4 x plus 1. So again, the trick here is to recognize that we were told it's a solution, right? We are told that this is a solution. We just have to find the a and b values. So we're going to plug in the same way that we did before. And this is a pretty good AP trick question, either as a multiple choice or a free response. So let's go ahead and give that a try on a P2. Same idea, right? You have y equals ax squared plus b. This is a solution, right, to this expression. So let's go ahead and give it a try. So I know that y equals ax squared plus b. I know that if I differentiate, dy dx should be a 2ax. So I can replace the y with the ax squared plus b. I can replace the dy dx with the 2ax, and we're going to see what happens. So I know that on the left-hand side, I have 2ax, and that's going to equal, on the right-hand side, a negative 6x squared plus 6x plus 2 times what the y expression was, plus 10. So let's walk through and see what we know. So 2ax equals a negative 6x squared plus, I'm going to go ahead and put this up here because this is also an x squared, so a 2ax x squared. Those are my x squared terms, right? Plus a 6x plus a 2b plus a 10. Well, so these are my x squared terms, these are my x terms, and this is my number, right? So right away, I know that this has to be true for all x, right? So since this has to be true for all x, I know that whatever's on the left-hand side, the x squared terms on the left have to equal the x squared terms on the right. The x terms on the left have to equal the x squared terms on the right, and the numbers on the left have to equal the numerical terms on the right. So on the left-hand side, there are no x squareds. There are x's, right? So let's start with the x squareds. There's no x squareds, and on this side, the x squareds seem to be negative 6 plus 2a. I think right away that's going to let me find a, right? But let's go ahead and go the rest of the way. So on this side, I do have x terms, right? My x term on this side is a 2a. My x term on the other side is a 6, right? So 2ax and 6x, right? So again, I think that's going to be the same step to let me find a pretty quickly. And then there are no numbers on the left-hand side, but on the right-hand side, my number is 2b plus 10. Well, if I solve either of the first two equations for a, I'm going to get that a is 3, right? Because either I get 6 equals 2a and divide by 2 and get a is 3, or I do the same thing with the red equation, and either way I get a is 3. For the green equation, I get negative 10 is 2b, so negative 5 is my b, right? So again, my answer, right, I wasn't actually asked to find the solution. I was asked to find a, which is 3, and b, which is a negative 5. But that means that the solution to the diffie-q, if you were asked to find it, is y equals a x squared plus, oh, sorry, I didn't write x squared. Come on, brain. I said x squared plus b, which would be plus a negative 5 or minus 5. So this is the answer you were asked to find, but that's what the solution would be. So that's kind of the idea. Again, this is something you might see on an AP, and I believe that that is it for this video.